Hey everyone, and welcome to our deep dives today. We're going to be exploring the factory design pattern in software development.
It's a good one.
It is a good one, and we're going to be looking at some exos from the source material you shared with me, O3 design patterns-factory.pdf.
Feels good.
So, have you ever had to create a ton of objects in your code?
Oh, yeah. All the time.
Like imagine building a travel app,
Yeah.
and you've got flights, hotels, rental cars. It gets really messy really fast.
Yeah, for sure.
That's where this factory pattern really comes in handy. And hopefully by the end of this, you'll be able to not only write cleaner code, but also appreciate the elegance behind it all.
The beauty of software design.
Exactly.
That's what we're going for.
So let's dive into this source material.
Okay, let's do it.
It seems like the factory pattern is all about making these families of objects without getting bogged down in the nitty-gritty of creating each one.
Yeah, that's a great way to put it. It's about taking a step back from the complexity of making each individual object and just thinking about the bigger picture.
So it's like instead of me having to go through all the details myself,
Yeah.
I can just tell this pattern, hey, I need a travel package.
Yeah.
And it figures out all the rest.
Exactly. You just tell the factory I need a travel package, and it takes care of figuring out whether that means a flight, a hotel, or a rental car.
So it's like having a personal assistant for my code.
I like that analogy.
Right. It just takes care of all the details for me. I like it. But how does this actually work in the code?
Well, there are a few different types of factory patterns.
Okay.
Each with its own kind of twist.
Okay.
Let's start with the simplest one, the simple factory.
I like simple. Tell me more.
The simple factory is essentially like a virtual constructor. So it's a single class with a method that takes some input, like what kind of travel package you need,
Okay.
and then churns out the corresponding object.
So instead of writing like separate code for each type of travel package, I just call this one factory method, and it takes care of everything.
Exactly, you got it.
Okay.
The source uses a travel agency called Acest as an example.
Acest.
Yeah, they offer different packages. So you've got Patchakazar for accommodation, Patchet Transport for transportation, and then Patchakazar Transport, which combines both.
Okay.
And they have this class called Agenty Factory,
Agenty factory?
which handles creating these different packages based on what you ask for.
Okay, so what's the real advantage of doing this instead of just creating those objects directly?
Well, imagine you didn't have this factory.
Yeah.
You'd be writing the same code over and over again every time you needed a new package, making your code a tangled mess.
Yeah, true. That would be a nightmare to manage.
Exactly. A simple factory keeps your code clean, organized, and easy to update. It's your go-to for straightforward object creation when you have one central point of control.
So if I wanted to add like a cruise package later on, I could just tweak the factory and everything else would just fall into place.
Precisely. That's the beauty of it.
That's pretty slick. I like that. So is there anything else? Is there another type of factory pattern?
There's another type of factory pattern that takes us a step further, and that's called the factory method.
Okay.
And it's kind of like adding specialized apartments to your factory.
Specialized apartments.
Mm.
Okay. I'm intrigued. Tell me more. How is that different from the simple factory?
So instead of one method handling all the object types, the factory method defines a separate method for creating each kind of object.
Okay, so our agency factory would have a separate method for creating accommodation, a separate method for transportation, and so on.
Exactly, you got it.
Okay, so wouldn't that make things more complex?
It might seem that way at first glance,
Yeah.
but it actually gives you a lot more control over how those objects are created. It's like having dedicated teams for each travel element, flights, hotels, you name it.
Okay.
So the factory method provides this targeted control over the creation of each object type, giving you a lot more flexibility in the long run.
Okay, so you have this master factory, and then it delegates tasks to these specialized departments.
Exactly.
Okay, I like that. Are there even more layers to this factory pattern? It
Right.
feels like we're going deeper down the rabbit hole.
You're catching on quickly. There's indeed another level, and it's called the abstract factory. Think of it as building a whole network of factories.
A network of factories. Wow. Okay, what makes the abstract factory so powerful?
So imagine Acest wants to offer different tiers of travel packages. Okay, so budget-friendly options versus like luxurious ones. Each tier would have its own types of hotels and transportation.
Okay, so like a budget package might have a 3-star hotel and a bus ride,
Yeah.
whereas the luxury package would have a 5-star resort and a private jet.
Exactly, you got it.
Okay.
With the abstract factory, you create a separate factory for each tier.
Okay.
These factories are then responsible for creating the specific sets of objects that belong to their respective categories.
We'd have like a budget travel factory making the budget-friendly packages and a luxury travel factory making the high-end ones.
Exactly.
And then each of those factories would have those specialized methods we talked about for creating the specific hotels and transportation options within their tier.
Precisely. That's how it works.
This feels like one of those Russian nesting dolls.
I like that.
Right? Factories within factories. It's fascinating.
It's a powerful concept. The abstract factory lets you switch between creating entire sets of related objects, ensuring everything fits within its category.
Wow.
It's the ultimate tool for creating families of related objects, giving you the power to swap out entire ecosystems of objects seamlessly.
Okay, so I'm starting to see how these patterns help organize like big, complex projects.
Absolutely.
It's not just about keeping things tidy, is it? What are some other benefits of using these factory patterns?
You're right. It's not just about tidiness. These patterns bring a whole lot more to the table.
Well, don't leave me hanging. What else is there?
First off, they simplify your code and make it easier to read.
Okay.
By centralizing all the object creation, you avoid a ton of repetition and make your code much easier to understand and update.
Less repetition is always a win. What else?
They also make your code much more adaptable. So if you need to change how objects are created or add new types, you only need to adjust the factory itself. No need to go hunting through your entire code base.
So it's kind of like future-proofing my code.
Exactly like having a control panel where you can just tweak the settings and everything else adapts.
I like that that's super efficient.
It is.
It's really interesting how these factory patterns can work together with other design patterns as well.
It's like they're all part of a bigger puzzle.
Yeah.
You can combine the factory pattern with the singleton pattern to ensure you only have one factory instance controlling object creation throughout your entire application.
That makes sense. You wouldn't want multiple factories kind of going rogue and creating chaos.
Exactly. You want to keep things organized.
Right. What other combinations are possible?
Another cool combination is with the composite pattern.
Okay.
Remember our travel agency example with different types of packages? You can use the factory pattern to create the individual components of a package and then use the composite pattern to assemble them into a complete travel experience.
So the factory kind of makes all the ingredients and then the composite puts it all together into like a delicious meal.
I like that analogy. It's a great way to think about it.
The source actually mentioned this, how these factories can be used for creating both the individual parts and the overall structure.
Yeah, it's a versatile pattern.
It is. I'm starting to see how these patterns are kind of like building blocks. They fit together to create these elegant and efficient software structures.
Exactly. That's the goal.
And at the heart of all these factory patterns lies a fundamental principle of object-oriented programming called encapsulation.
Oh, yeah. Encapsulation is key.
Can you break that down for me?
Think of it like this. You have this neat little box that holds all the object creation processes. The rest of your code doesn't need to know about the mess inside the box.
Right.
It just interacts with the box itself. That's encapsulation, hiding the complexity and making your code cleaner and easier to manage.
That makes a lot of sense. So it's not just about making things look neat. It's about making the code itself more robust and easier to work with over time.
Absolutely. That's the goal.
Okay, cool. So let's pause and recap what we've learned so far about these factory patterns. We explored three types: simple factory method and abstract factory. Each one has its own way of managing object creation, but they all share the goal of simplifying complexity and making our code more flexible and maintainable.
Well summarized. You got all the key points.
And we saw how those patterns can team up with other patterns like singleton and composite to create even more sophisticated solutions.
It's like building an army of design patterns to tackle any problem.
It's like an entire ecosystem of design patterns working together. But let's bring it back to you, the listener. Why should you care about these factory patterns? What's the takeaway here?
That's a great question. You know, whether you're writing code or just using software, understanding these patterns can help you appreciate how well-designed software comes together.
So even if I'm not a programmer, I can still understand the logic behind the software I use every day.
Exactly. It's like peeking behind the curtain and seeing how the magic happens.
Maybe one day it might even inspire you to build your own amazing software creations.
That's the spirit.
So before we let you go, let's leave you with a little something to ponder.
Okay, I like it.
Think about how you might apply these factory patterns to your own work. Or if you can spot them in the software you use regularly, are there places where object creation gets a little messy or repetitive?
Yeah.
Could a factory pattern help streamline things and make your code more elegant?
That's a great challenge.
And remember, the beauty of software design lies in its ability to solve complex problems with elegant solutions.
Beautifully said. Now go forth and create.
Exactly.
It's fascinating how these design patterns, like the factory pattern we've been talking about, have become almost like a universal language among developers.
Yeah, it's true. It's like they've found these recurring patterns in the problems they solve, and those patterns have evolved into this shared vocabulary for tackling complexity.
Precisely. And it's not even limited to like a single programming language or framework. These patterns can be applied across various technologies and fields.
It reminds me of architectural blueprints, like whether you're building a skyscraper or a cozy cottage. Certain design principles always apply.
I like that analogy, just like understanding those principles helps you appreciate a building's design, and understanding design patterns in software helps you appreciate well-crafted code.
Okay, so for someone like me who's just starting out, where can I learn more about these patterns and start using them?
Well, one classic resource is the Gang of Four book, formerly known as Design Patterns, Elements of Reusable Object-Oriented Software.
Oh yeah, the GOF book. I've heard whispers of this legendary text in the coding community.
It's considered the Bible of design patterns. It covers a huge range of patterns, including the ones we've discussed, and explains them in a clear and concise way.
Sounds like essential reading for any aspiring software architect. Are there any other resources you'd suggest?
Absolutely. There are tons of websites, blogs, and online courses dedicated to design patterns. A quick search for software design patterns will unlock a treasure trove of information.
And I bet there are also open source projects where you can actually see these patterns in action.
You bet. Studying real-world code is one of the best ways to solidify your understanding of how these patterns are used.
It's like getting a behind-the-scenes look at how the magic happens. But beyond just writing more efficient code, I'm curious about how these patterns affect communication between developers.
That's a great point. Imagine working on a large project with a team of developers. Using these established design patterns can make sure everyone understands the code's structure and logic.
It's like having a shared blueprint that everyone can refer to.
Exactly. It reduces ambiguity and makes collaboration so much smoother. Instead of explaining every little detail of how a piece of code works, you can simply say, we're using a factory pattern here, and everyone immediately knows what you mean.
It's like a shorthand that streamlines communication and avoids all those frustrating misunderstandings.
Right, and this shared understanding makes it so much easier to maintain and expand the code base in the future.
It's like having a well-organized library where everyone knows exactly where to find the book they need. And speaking of libraries, do any programming languages or frameworks have built-in support for these common design patterns?
They do. You often don't even have to write all the code from scratch.
No.
You can leverage existing libraries or frameworks that provide pre-built components based on these patterns.
Oh, wow. That sounds like a huge time saver.
It is. It's like having a master carpenter provide prefabricated walls and beams instead of having to saw and hammer everything yourself.
Right. So it's about working smarter, not harder.
Yeah.
I bet we see examples of these patterns in the software we use every day without even realizing it.
Absolutely. Think about web frameworks like Ruby on Rails or Django. They rely heavily on design patterns for structure and organization, or game engines like Unity or Unreal Engine, which use patterns to manage complex game logic and rendering.
So even if I'm not writing code myself, understanding these patterns can give me a deeper understanding of how the software I use is designed and how it works.
Exactly. It's like being able to appreciate the architectural patterns in a beautiful building, even if you're not an architect yourself.
It's like a whole new level of understanding and appreciation for the technology we use daily.
And it's not just about recognizing existing patterns. Once you understand the basics, you can start adapting and combining them to create your own unique solutions.
So it's like learning the rules of jazz music so you can improvise your own melodies.
Exactly. That's where the real fun begins. But let's bring it back to the O3 design patterns -factory.pdf document for a moment.
You're right. It's easy to get carried away. How does the document connect to this broader world of design patterns?
Well, the document focuses specifically on the factory pattern, offering a deep dive into its variations: simple factory, factory method, and abstract factory. It uses the travel agency example to show how these patterns manage the creation of different travel packages.
Right, and we've seen how that example can be applied to other areas like building web applications or game engines.
The document is a great starting point for understanding the core concepts of the factory pattern. As you explore further, you'll see how these principles apply to a wide range of other patterns.
It's like learning the alphabet of software design. Once you know the letters, you can form words, sentences, and stories.
What a great way to put it. And just like with language, the more you practice and experiment with these design patterns, the more fluent and expressive you'll become as a developer.
It's a journey of continuous learning and discovery. But before we embark on our next coding adventure, I have a question that's been on my mind.
Go ahead. I'm listening.
We've talked about all these advantages of using design patterns, but are there any potential downsides or things to watch out for?
That's a great question. It's important to remember that design patterns aren't like a magic solution for every problem.
Right.
They're powerful tools, but they need to be used thoughtfully.
Oh, okay. So I shouldn't just try to apply a pattern to every problem I come across.
Exactly. One potential pitfall is over-engineering. Sometimes the simplest solution is the best. Using a design pattern when it's not necessary can make your code unnecessarily complex.
It's like using the sledgehammer to crack a nut.
Precisely. And remember that design patterns are guidelines, not strict rules.
Okay, so you need to adapt them to your project's specific needs instead of blindly following a recipe.
Exactly. And sometimes you might even need to come up with your own patterns to solve unique challenges.
So it's not just about memorizing existing patterns, but also about thinking creatively and finding innovative solutions.
Absolutely. That's what makes software development such an exciting and rewarding field.
It's this constant dance between art and science, between structure and creativity.
Well said. One of the most valuable skills you can develop as a developer is knowing when a design pattern is truly helpful and when it might be overkill.
It's about finding that balance between elegance and practicality, right?
Exactly. And finding that balance often comes with experience and a deep understanding of the different choices you can make.
It's like being a chef who knows when to add a pinch of spice and when to let the natural flavors shine through.
I love that analogy. As you gain experience, you'll develop a sense of when to use a design pattern and when to keep things simple.
It's all about using the right tool for the job.
Exactly. Just like a skilled craftsperson. A good software developer knows how to choose the best tools and techniques to create elegant and efficient solutions.
It's a craft that requires both technical expertise and artistic vision. Now, it's really interesting how these design patterns mirror the patterns we find in nature.
It's true. It's almost as if software developers are drawing inspiration from the natural world's elegance and efficiency.
Precisely, think about the patterns in a spider's web, the branches of a tree or the symmetry of a snowflake. These patterns evolved over millions of years to solve problems in nature.
And in a way, software developers are doing the same thing. They're finding recurring problems in software design and coming up with elegant, reusable solutions.
So it's not just about copying nature, but recognizing that good design principles are often universal.
Exactly. This connection between software design and the natural world reminds us that there's beauty and elegance in well-crafted code.
It's like uncovering the hidden poetry in a technical and complex system.
I love that analogy, and that appreciation for elegance and efficiency is something that sets great software developers apart.
It's not just about making the code work, but crafting it in a way that's both functional and beautiful.
Absolutely. And that's where design patterns are so crucial. They provide a framework for creating code that's not only effective, but also aesthetically pleasing and intellectually stimulating.
It's like the difference between a hastily built shack and a meticulously designed architectural masterpiece. Both might provide shelter, but one is clearly more inspiring and enduring.
Well said. This pursuit of elegance and efficiency isn't just about personal satisfaction, though it also benefits the software development process as a whole.
Oh, how so?
For one thing, well-designed code is usually much easier to understand and maintain. Using design patterns effectively creates modular, reusable, and predictable code.
So it's less likely to have those hidden surprises that cause headaches down the road.
Exactly. And this predictability makes it easier for teams to work together when everyone understands the underlying patterns and conventions. It minimizes miscommunication and errors.
It's like everyone's speaking the same language fluently.
Precisely. And that shared understanding can significantly speed up development and reduce costs.
So it's not just about making the code look pretty, but also making it more efficient and cost-effective to work with.
Absolutely. It's worth noting that the O3 Design Patterns -factory.pdf document reflects this emphasis on elegance and efficiency.
Oh, interesting. How so?
Well, the document shows how the factory pattern reduces code complexity and improves readability. It highlights the benefits of organizing object creation and making the code more modular and maintainable.
So the document aligns with this broader goal of striving for elegance and efficiency in software design.
Exactly. It's a reminder that these principles are fundamental to good software engineering, no matter which patterns you use.
It's like having a solid foundation to build upon.
Well said. As we wrap up this part of our deep dive, I'd like to leave our listener with a challenge.
I'm intrigued. What's the challenge?
The challenge is to step back from the technical aspects of design patterns and think about the bigger picture, the values of elegance, efficiency, and simplicity. how can you apply these values to your own work, whether you're coding or tackling any other complex problem?
It's a challenge that goes beyond software development, inviting us to approach everything we do with a sense of artistry and purpose.
Beautifully put. I believe that by embracing these values, we can not only create better software, but also lead more fulfilling lives.
That's a powerful thought on that note. I think it's time to continue our exploration in the final part of this deep dive.
Yeah, that was a great point about applying those design principles to life in general. But I think it's time to kind of shift gears back to the factory pattern for a minute.
Okay, sounds good to me.
We've covered a lot of ground so far, from the different types of factory patterns to their benefits and potential pitfalls. But I'm curious, what are your thoughts on how these patterns have evolved over time? That's a fascinating topic. You know, design patterns aren't static. They're constantly evolving as new technologies and programming paradigms emerge.
So they're not just a set of rules set in stone,
Right.
but more of like a living body of knowledge
Yeah.
that adapts and grows.
Precisely. And this evolution is driven by the collective experience of countless developers all over the world who are constantly pushing the boundaries of what's possible with software.
It's really amazing to think about how this global community of developers contributes to this shared pool of knowledge.
It truly is a testament to the power of collaboration and open sources. The shared knowledge empowers us to create things that would have been unimaginable just a few decades ago.
It's crazy how far we've come.
Yeah.
And with technology advancing so rapidly,
Yeah.
who knows what incredible innovations await us in the future.
It's an exciting time to be a software developer, that's for sure. And even if you're not a programmer, just understanding these design patterns offers a glimpse into the ingenuity and creativity that's driving this incredible field.
It's like having a front row seat to witness the future unfolding.
I couldn't have said it better myself before we wrap up our deep dive into the factory pattern. I want to revisit the O3 design patterns-factory.pdf document one last time.
Okay, yeah. What specific aspects did you want to highlight?
Well, the document emphasizes reducing code complexity and improving readability through the factory pattern. It underscores the importance of a centralized approach to object creation for enhanced modularity and maintainability.
So it really reinforces this broader principle of striving for elegance and efficiency in software design we've been talking about all along.
Exactly. It serves as a reminder that these principles are the bedrock of good software engineering, regardless of the specific patterns we employ.
It's all about laying a strong foundation for building this robust and elegant software structure.
Well said. As we conclude our deep dive today, I'd like to leave our listener with one final thought.
Okay, what's that?
Remember, the true essence of design patterns lies not only in their technical implementation, but also in the underlying principles they represent. Embrace the values of elegance, efficiency, and simplicity in all your endeavors, whether you're writing code or tackling any other challenge in life.
That's a really powerful message that goes way beyond software development. It's a call to approach everything we do with intentionality and a commitment to excellence.
You've captured it perfectly. By embracing these values, we can create not only better software, but also a more beautiful and fulfilling world.
That's a really inspiring thought to end on. Thank you so much for guiding us through this deep dive into the factory pattern.
It's been my pleasure. Keep exploring, keep learning, and keep creating.
And to you, our listener, we hope you enjoyed this deep dive as much as we did. We'll catch you in the next episode.